my name is Christina Hastenrath, and today I'm going to speak about GraphQL caching and take a look at limitations and possibilities around different caching options with GraphQL. Oh, sorry. But first, who am I? My name is Christina, and I'm a software engineer at Postman. I grew up in Germany and now live and work in beautiful California with my husband and my 18-month-old son. Why am I interested in GraphQL caching? Because I've heard many a times that it's not possible, and that got me curious, and I decided to look deeper into the subject and see if caching with GraphQL really is that hard or even not possible, and what app services are out there that can help with caching. I want to bring the knowledge that I found to you and also back to my team for our next GraphQL project. So today I will give you an introduction to what I found. Okay, sorry. So what am I going to cover today? First, I want to look at caching in general, HTTP caching with GraphQL, what the GraphQL specification says. We want to look at globally unique ID patterns, GET requests with GraphQL, and how you can outsource caching as well. So first, a short overview over what is GraphQL. In a nutshell, it's an open source query language and data manipulation language that you can use to deliver structured API content to clients. This ensures that clients receive exactly the content that they request, while preventing both overfetching and underfetching of the data. GraphQL consists of both a query language and an API server, which hosts the GraphQL schema. This is essentially all your available operations for your application. The GraphQL server executes a query and provides the response in the JSON document to the client. The combination of easily written and human-readable query language and type system provides a powerful and flexible way of fetching data. But how can you avoid refetching resources? GraphQL has no native query cache to avoid refetching of any resources. What is caching? One thing we can learn from computer science is that reading from a database is slower than from memory. And the caching definition from Merriam-Webster Dictionary is a computer memory with very short access time used for storage of frequently or recently used instructions or data, which is also called a cache memory. Caching, in a nutshell, is storing for reusing. Caching is essentially storing the data in a temporary storage called a cache, and when you return to a recently visited page, the browser can get the data from the cache instead of the server. So the purpose of the cache is to take the load of something and to make that load available to another process or system. This saves time and additional traffic and load and improves the performance of data displayed inside of your application. In web apps, the data can be cached at the server, the middle tier, and the client level. Caching is not possible with GraphQL, and other protocols like REST clients can use HTTP caching. The URLs of a resource-based API provide a globally unique identifier for a given object that the client can identify when two resources are the same and then build a cache. This avoids refetching resources and makes the application robust and performant. So a big benefit of REST is that under the URL that accesses a request, you can save the response in a cache. You might have heard that GraphQL breaks caching or GraphQL is not cacheable. Reasons for that are probably that GraphQL's power lies in the single endpoint, So the response data that comes from a route under URL cannot simply be saved. The general expectation that GraphQL cannot cache comes from the fact that GraphQL does not natively support caching, really. I went to the specification and I found one small reference to caching that I'm going to share with you later. The GraphQL documentation, however, gives a little bit more detail that I also want to look into. But first, I would like to understand better REST HTTP cache and then take a look at what options there are to create a localized cache with GraphQL. So HTTP caching is wonderful for data that does not change very often and is shared to various users. Different entities can be involved in HTTP caching with REST. So there can be the client-side cache, like a browser cache, that does not refetch data that is still fresh. There's also a gateway cache that is typically deployed along with the server and makes sure that the data at the cache level is up to date in order to prevent always hitting the server. The resource does not have to necessarily be affected by change, though. So in order to control client and gateway caches, there are two concepts called freshness and validation. Freshness provides a cache control with a max age or no store value and expires HTTP headers. A server that returns a cache control essentially tells the client not to refetch that particular resource until it has been the time defined. For example, after 1 hour, the client will refetch from the server instead of using its cache. So the example would be cache control and then the max age set to 3600. Validation can provide a way for clients to determine if the resource is indeed fresh or not. This can be achieved by adding a last modified value on the server HTTP cache so that the client can see a if modified since HTTP header to check if the resource changed since the last download. Another way of validating caches are e-tags that the server generates for the client to track what version it has and then downloads the representation for which the e-tag is different. Understanding how REST HTTP cache works on a high level, we can already see the issues with GraphQL and caching that are related to HTTP caching. So it is important to make the distinction because so there can also be server-side caching, but that could also mean HTTP gateway cache or application-side caching on the server. The problem is that HTTP caches will not cache post requests, and since that is used on the GraphQL client, the general thought is that GraphQL is not cacheable at the HTTP level. But maybe instead of asking how can we cache GraphQL, we could also ask ourselves, in order to use HTTP caching, how should we use GraphQL? So let's take a look. If you want to cache using HTTP, you will need to use the URL as an identifier to cache the GraphQL response. This means that we have to access GraphQL's single endpoint via a GET request and thereby passing the query and the variables as URL parameters. Here's an example on how to query a GraphQL server over HTTP so that caches can be indeed cache the GraphQL response. So we have the single endpoint /GraphQL, and then we have the GET request with the query. But what about mutations? Most GraphQL servers will allow a mutation together with the GET request. But since that does not work with caches, one option would be to design the server to only require mutations run on post. And mutations are always executed fresh. So we would not need to use HTTP caching here necessarily. Okay, let's take a deeper dive in how we can how we can use the query as URL parameters. One way is to encode the query by the graphical client, but that makes it pretty unreadable for humans, as you can see here on the top row. And that takes away one of the virtues of GraphQL. So another way is to add spacing to replace new lines of the query. And the GraphQL specification actually says that new lines in GraphQL have no semantic meaning in the query. So this would turn the query into a more readable format. And this looks nice for short queries, but for long queries with many opening and closing brackets, and when fragments come into play, this can become pretty difficult to read as well. So in addition to that, some browsers have different limits for query string sizes. So another way would be to use persisted queries to store query strings on the server as opposed to the client. And the query on the server then can be retrieved by a unique identifier, such as an ID or a unique string. And then we pass the identifier to the URL parameters instead of the query. So the client could execute the GET request and then /GraphQL and then the unique identifier. The GraphQL server will get the query corresponding to the identifier, execute it, and then return the results. So this can solve implementing HTTP caching in your GraphQL server that supports the persisted queries. It can do that natively or through a library as well. Overall, HTTP caching with GraphQL is a recognizable challenge in the community, so much so that a group of stakeholders have gotten together to work on a GraphQL over HTTP specification, which will one day standardize how GraphQL servers, clients, and libraries communicate their GraphQL queries via URL parameters. And I have the link here on the bottom of the slide if you're interested. Now the service can generate a cache control header with a max age value, and our GraphQL server can fetch the cache control header and add it to the response. With validation, this is a similar story to Freshness because it's not possible to revalidate only parts of the query. So one option could be to create an E tag that is based on all of the data loaded within the query. And another option would be to set the last modified to the value of the field with the oldest last modified value. So all options that we looked at so far are possible, but not great for implementation and caching. It is possible that we're working with multiple entities that could change and need to be one representation on the GraphQL side. Therefore, if one field would invalidate and remove any state content in the cache, it would invalidate the entire query. So the invalidations could be very high, and this would make us lose all cache queries and therefore the benefit of caching. Right. What does GraphQL specification mention? In the GraphQL specification under 3.5.5 mentions the usage of unique identifiers for caching. So the ID scalar types is a unique identifier that is often used to refetch an object or as the key for a cache. So the ID type is not meant to be human readable and should always be serialized as a string. So what does that mean? GraphQL executes all queries via post against a single endpoint and passes the parameters through the request body. The single endpoint will therefore bring back different responses based on the queries, and that cannot be cached using URL as an identifier. In GraphQL, there's no URL-like primitive that provides a globally unique identifier for a given object. And the critical functionality that the client needs for caching is the ability to derive a globally unique identifier. So one solution to this is to expose an identifier in the API for client developers to use. So a field in the schema can be reserved, such as ID, that can provide a globally unique identifier to client developers. Here on the right is an example for a schema. And this can be a straightforward approach if the backend uses UUIDs or similar identifiers, so the server derives the ID. If not, then the GraphQL layer may have to provide it, or in other words, the client can derive the identifier. This can be done by appending the name of the type to the type of the object to the ID and use that as an identifier. The type of the object can be then queried with __ type and added to a unique identifier, which the server then can base64 encode to make the ID opaque. What about existing APIs? So what if the client that uses the GraphQL API uses this ID field to work with already existing APIs, and we want to replace those with our GraphQL API? So what happens if GraphQL uses globally unique IDs and the existing API accepted as type-specific ID? All the fields would be the same except for the ID field. How could we solve that if we wanted to replace them? In this case, we can have a separate field with the previous API ID that can be exposed by our GraphQL API. So clients that work with the previous API can fetch the previous API ID from the object and use that, and GraphQL clients will keep getting a globally unique ID. However, a newly constructed ID could also be utilized to work with the global object identification node pattern. As I mentioned before, GraphQL servers should expose object identifiers in a standardized way for GraphQL clients to handle caching and data refetching. In addition, the client needs a standardized way of querying an object ID, and the schema needs a standardized way of providing these IDs. When the object is virtually unknown except for its ID, you can call the object nodes, and the schema is formatted to allow the fetching of any object via the node field on the root query object. So you can see a query example here on the top, and a node interface can then be returned. In case this is unknown, an interface is an abstract type with a certain set of fields, and if a type wants to include the interface, it has to include all the fields in the interface. So an interface is being returned, and the ID can be taken out of the response and cached. And you can see a node interface example here on the bottom. Okay. GraphQL breaks server-side cache. This is not exactly true. GraphQL does not prevent server-side caching, which can also be referred to as application caching. Even when GraphQL is a thin layer over the existing servers, some people might refer to HTTP gateway cache or application-side caching on the server. Popular GraphQL clients like Apollo and Relay denormalize cache, which avoids refetching data that the client already has. And this keeps a consistent version across components. So you can look more into GraphQL and server-side caching outside of this talk. I recommend it. So how can I outsource caching? Looking at all the previously mentioned options and how you can use GraphQL to support caching, depending on your GraphQL implementation, this can become very tricky. I was very excited when I learned about Stellate, and I will show you how easy it is to cache your GraphQL API. There are other providers out there, such as Apollo and Hasura and so on. You can use caching, but for the rest of the time today, I would like to show you how easy it is to cache your GraphQL API with Stellate. So I have at first, one second here. So I used a Airtable and Airtable GraphQL starter from Ibrahimi92 on GitHub to create a to-do list. And here you can see my GraphQL, the resolvers, and the server. And with this starter, I connected Airtable with the API, and I deployed it to Netlify. And then all you have to do is, once you get your API URL, you can go to Stellate, you can create a new service, and then you can paste in your endpoint here. And that's pretty much most that you have to do. And then you then take the Stellate URL, and that you then paste into your GraphQL fetch query here in order to cache the results. And we don't have that much time left, so I'm going to show you the screen shots that I took. So this is my GraphQL API. Here is the Airtable GraphQL starter that I highly recommend. And here you can see that GraphQL without Stellate loads at 200 milliseconds in the network tab. This is a very small table with only a couple of entries. And once I added Stellate, and you can see here is the cache with the hit, and this already went down to 29 milliseconds. So with such a tiny API, this already makes a huge difference in speed. So thank you very much for joining my talk. In summary, there are several ways that you can use GraphQL to support HTTP caching, and it does not block server-side caching. Depending on your GraphQL implementation, this can become very complex, and outsourcing, I think, is a great idea, and apps like Stellate make it very easy. They also make the process very enjoyable, and they have a lot of metrics that come with it, so you can look at everything surrounding your GraphQL API in nice dashboards. Thank you very much. This concludes my talk. Thank you.